Hello, and thank you for joining us on the presentation portion today at the Al-Attiyah Foundation Pavilion on Water Day, the thematic day on water. And today's topic, our presentation today, is going to focus on the concept that water is really one of the biggest blind spots when it comes to global climate discussions and negotiations. And my objective here is to walk you through that to better understand why that is and what could be some ways where that could change moving forward into the future. So one of the important things to understand is that the importance of water, certainly with respect to climate, is actually understood. And what we mean by that is there's certain examples when we look at, for example, the World Meteorological Organization has put out as part of their reporting, we cannot afford to wait. Climate policy makers must put water at the heart of action, of climate action and action plans. Similarly, the UNDP has indicated through its various reportings and documentation, and is the case, 80% of the impacts of climate change are water related. And then UN Water had put out a policy brief earlier this year on climate change adaptation and the pivotal role of water in that. So even though the importance of water with respect to climate is understood, it is still quite understated. And I'll give you examples on why that is, especially if we think about the climate negotiation, climate discussion context with COP and the Conference of Parties. For example, very mixed in terms of positives as it relates to water inclusion and maybe areas of improvement. So in COP26 in Glasgow, for the first time, there was a water and climate pavilion. But similarly, or in the flip side of that, I should say, water was not part of the thematic days of the presidency program. So quite a stark contrast. Follow up next year, COP27 in Sharm el-Sheikh. There was finally an agenda thematic day that was dedicated to water. But contrary to what would have been expected, no significant progress in advancing water was as part of the global adaptation efforts really substantially took place at that conference. Now we move on to where we are today in COP28. And there has been a strong emphasis in food security and energy transition, as was expected and as part of the agenda strongly, but still feels that the critical role of water in achieving those objectives are still quite overlooked. And I want to take a minute to talk about that, just to really highlight how overlooked they are and how critical water resources are, especially for food security and to a lesser extent, the topic of energy transition. And to do that, I think it's best to view and look at the water, energy, food nexus, because it really does highlight the importance of water as a critical component, the two aspects of that nexus. Water security is very critical in terms of providing food security. Water is essential in terms of food production. We'll talk a little bit more about that. And then also water plays a role to a certain extent when it comes to issues or topics of energy production that are helpful in terms of achieving energy security or even energy transition in the COP context. So let's talk about the food portion and how that relates to water. And it really is as simple as saying that water security is food security. On average, about 60 to 70% of a country's water use goes towards agricultural food production. And that means that reliable water supplies have to be available to support that level of food production and that amount of water consumption. If we look at the region where we are today in terms of the Middle East and North Africa, the Middle East itself is a really extreme example of how dire water scarcity is and how that translates to uses such as agriculture. MENA has limited freshwater resources. There's only very few significant transboundary water resources or surface river systems, like the Nile or the Tigris-Euphrates or the River Jordan. But the region has historically depended on groundwater, and those have groundwater resources, and those have been historically declining and depleting as a consequence. in most of the region, not all of it, evapotranspiration far exceeds the amount of minimal rainfall that it receives. So naturally, in that regard, the region is in a state of water deficit, a water balance deficit. So as a consequence, the MENA region is highly dependent on non-conventional water supplies. Large parts of the region really depend on desalination as a source of water supply in the absence of freshwater resources. And then other non-conventional water uses such as water recycling or wastewater reuse also help to meet some of that gap. So let's shift to water and energy. Water also plays an important role, or a role, in terms of clean energy transition. And I'll pick a couple of examples that highlight that. One, I think the easiest one is the example of hydropower or hydropower generation, either conventional hydroelectric plants or pump storage type hydroelectric plants. Water is stored in a reservoir, it's discharged, and through the movement of that discharged water through the turbines, you generate electricity. It's clean, it's to a certain extent considered renewable. If it's pump storage, it truly is fully renewable. But water is also used in very basic elements of power generation. Power plants that require cooling towers utilize water to be able to have those cooling towers operational. And then in thermoelectric plants, steam is essential as a form of generating electricity. But the one thing that I want to highlight more is that's sort of come up more in conversations as part of the energy transition as a new, maybe not new, but alternative form of energy that's low emission or some degree almost no emission, is this idea of green hydrogen, which is based on the electrolysis process, which is essentially separating the hydrogen from the oxygen in water. And so it is a form of energy that is highly dependent, almost exclusively on the availability of water. So as those discussions increase and the idea of incorporating green hydrogen as part of the energy transition, water availability becomes even more important for the energy sector. Shifting a little bit outwards in terms of global water security, a lot of the focus from the global perspective on water security is on issues of water access, availability, and quality. And this is really because it's an emphasis on the UN Sustainable Development Goal 6, which is really about clean water and sanitation for all. And it makes sense why that would be the case. A quarter of the world's population don't have access to safe and clean drinking water. And these are current numbers as of this year, based on, I think, the UN Water Report from earlier this year. And almost half of the world's population doesn't have access to sanitation services. So it makes sense that the global water security perspective is on those very basic fundamental tenets of achieving water security. But there is more to water security than issues of water quality. In fact, secondary issues of supply, demand, conveyance, and management are also important. And you see this more in the developed world versus the developing world, where you tend to see more of the focus on water quality in SDG 6. But these secondary issues begin to address more complex correlating topics, such as economic growth, population increase, and urban expansion. And water security under accelerating and amplifying climate change requires attention in several areas. Water resources reliability as it relates to water supply and demand planning, issues of water operations as it relates to water conveyance, and then water policy and regulation as it relates to water management. And to break those down, let's look at the different climate impacts to those different areas. So climate impacts to water supply are derived from one primary issue, which is warming has a direct correlation to drought. And when we think of that, surface water systems, such as rivers and streams, are really affected in two ways when we think about warming because of drought. Those systems that rely on water being generated from higher elevation will experience less water being generated at those headwaters because there's less precipitation or sublimation of snow at those higher elevations. And then there's generally a higher rate of evaporation across the run of the river or rivers because of the warming, and that ultimately translates to less water available downstream. What does that all mean? That means there's going to be pressure on other water resources. And in that regard, to make up that shortfall, that pressure increases in both other freshwater supplies or non-conventional water supplies, depending on what is available to each respective country. Groundwater gets pressure, that accelerates the depletion of that finite resource and aquifers. There's more pressure on desalination, that increases energy demands. More pressure on water reuse, so that spikes up infrastructure costs and increases or demand for that type of application. And then other less utilized water augmentation strategies begin to gain prominence, such as things like rainfall enhancement or cloud seeding. When we think about impacts to water demand, we have to think about the primary sources of water demand. We talked about the highest being agricultural water use, highest consumptive use, but even things like urban water use to satisfy drinking water, residential water use, sanitation, those are impacted by warming and by climate change. Even industrial uses, such as for manufacturing and energy production, resource extraction. Under warming, water demand across all sectors will generally be inflated in contrast to the fact that there's less water supply to meet the same demand. But what actually also happens, the demand itself inflates. And you see this prominently, the example I use again, in agriculture, the highest consumptive use. More evaporation doesn't just mean there's less supply, but in terms of the agricultural water use itself, the amount of water needed is going to increase because irrigation requirement increases when there is more evaporation. Because for the same amount of crop, for the same type of crop, same amount of water, usually you'd have to apply more water to offset the increased evapotranspiration that occurs. When we think about water conveyance, climate impacts there include issues related to the transmission of water. That's what we talk about when we say water conveyance. When we transmit water from source to utilization. And that could be through natural conveyance means as rivers and streams, but also artificial conveyance through open channel canals or pipeline. And climate change threatens the reliability of the infrastructure that we're able to convey water through due to primarily extreme heat and extreme weather. Those things cause accelerated wear and tear on all types of infrastructure. They reduce the lifespan of critical assets and then elevate at a dramatic level the risk of infrastructure failure. So those become very, very important things to consider. And then overall, there's an impact to water management. When we combine all these different components of supply, demand, conveyance, and they generate larger water management issues. Less water storage in dams and reservoirs because of evaporation and reduced flow. You have also transboundary issues between nations that share river systems, upstream and downstream. Tend to see a situation of water hoarding between nations, diminished water quality, pollution, and freshwater sources due to extreme weather events, dust storms, thunderstorms, that type of thing, flooding. And then with reduced flow in these streams and rivers, there's saltwater intrusion into some rivers that discharge into oceans and ocean bodies, but also saltwater intrusion into groundwater aquifers. So now a freshwater supply is compromised and contaminated. Water infrastructure, we talked about how extreme weather and climate could affect that. Sea level rise could put a lot of critical water infrastructure on the coast at risk, such as desalination plants, water treatment plants, and really anywhere where there's coastal communities that have built infrastructure is truly under threat under sea level rise. And then you start to see with the diminishment of water resources, the potential of conflict between the different sectors of water use, urban versus agricultural versus industrial, or even within those sectors, different types of uses over the limited water resources. And overall, rising cost of water services for consumers due to less water available and higher unit cost of water. So ultimately, what we begin to see is that many climate change impacts have a connection to water. And similarly, the good news is many climate change adaptation and mitigation strategies also involve water. When we think about resolving issues of food production, ocean bodies as carbon sinks, improving urban resilience, the ability to provide services of sanitation and water, water recycling, public health, on issues of water quality, and as we had mentioned in the beginning, energy generation. So the question really becomes, we've talked about how critical water is in terms of addressing a significant portion of the climate crisis. Then really the question is, how do we address the water gap in terms of global climate efforts? And what I mean by that, how do we elevate water as a key part of climate negotiations and climate discussions? And I don't necessarily have the answer, but I will posit some questions that I think hopefully will provoke people to think a little bit more about this. One idea that's been floated around is, should there be a water COP? There's one for biodiversity that has their own proceedings and produce their own agreements. And there is benefit to that in terms of elevating the water issue at a high standard at its own potential conference proceedings, a la the COP meeting we are in today on an annual basis. And some even talked about developing our own water equivalent of a Paris Agreement, elevating water to a point that we can get nations to agree on very high level goals in terms of achieving global water security. But there is a risk with that. And the risk is we may further downgrade or disenfranchise water as a critical topic from the rest of the climate discussions if we do remove that from the COP proceedings as is today. But then that begs the question of, if we don't follow that track or continue to try to push water higher into the COP agenda, how can we make water more inclusive in terms of the climate and water nexus? There's simple steps, at least simple suggestions that maybe require more effort and execution, but one way simply is to engage water experts across the spectrum, not just those that are focused on topics or issues that have been put forth by the United Nations or the COP presidency, right? So food security is important, but just talking about water in the context of food security doesn't get to the issue of a water scarcity and water reliability before you can actually talk about food security, because that's not possible unless you address the water component. And then the other suggestion is making water security and reliability an agenda priority as a prerequisite to assuming the benefits of water in other sectors, whether it's in food production, whether it's in energy generation, or the rights of access of water by indigenous peoples and youth and disenfranchised people. So it's really important to make sure that water is high on the agenda in different tracks. It's an ongoing challenge, and we're certainly always open to new ideas and solutions. So I'll just leave you with a couple of things. If you're curious to know more about the role of water in the global climate agenda, today at almost the end of today, there's going to be a panel discussion on sustaining the oasis, policy insights on water security and climate change and ethics at 4 p.m. Local time UAE at the Qatar Pavilion. And of course, you're always welcome to check out the Middle East Institute Climate and Water Program page, where we continuously provide research analysis on issues of climate, water, environment, and all things in between. So thank you very much. Yes, sir.